is in engineering, in the engineering, electronic engineering, C programming is like is the core.
Oh, it's the
So
core
most of
language of the
so
program.
most of these microcontrollers, most of these chips, they can be easily programming into C programming. And then most of these environments that you can actually use to program, they have C and C++ as well. In the past 3 years, when I finished university, so I graduated in 2018, summer 2018, and soon after I started working for a company in the UK that they were basically designing telecommunication equipment for big companies, big telecommunication companies like Virgin Media, Vodafone, and um, BT and such. So it was a very good entry level. I managed to learn quite a lot, and basically my day to day. I mean, before starting my job title was research and development engineer, junior engineer.
Interesting.
Yeah. So which is some kind of a job that requires you to actually design products from the conception until the handing in. So
It's quite
before,
exciting, you know?
yeah. So what I learned at university, it was kind of like the university gave me the tools, the basic tools to
Yes.
basically apply on my daily basis. So it was like we had many modules that were basically designed through application in industry. So my first 6 months at the company was mainly training. So I
Okay.
went through a 6 month training, and during the training, I was being basically mentored by the most experienced engineer at the company.
That's good.
So they taught me so many things that I didn't know. I mean, at university, you are like concatenated in that place that you
Yes,
feel
indeed.
like okay, but when you come to the industry, you see what is really how big is the field.
Yeah.
You start learning. I mean, you start learning even more. It's
Yes.
just a continuation. You
Mm-hmm.
start learning even more. You start picking up more technical aspect of your design. You start learning how to design products and how to think about safety, design aspects, also the feasibility. Um, I mean, like there were various aspects that when you are at university, you actually don't think about it because
Yes,
it's more
you don't.
academic. But when
Yes.
you come to the real world, it's more profitable. So
Yes.
you need to think about it, how you can actually help the company make money, because
Make
this is
money.
the actually, yeah,
Yeah, bring
because
value.
this is the actual purpose of
Yes,
the
indeed.
industry. The industry are there to serve the needs of the people, but
Yes.
also they are there to make money
Yes.
at the end of the day.
Mm-hmm.
So they'll teach you that you just need to be the adventures and have that hunger to actually know. I
Yeah.
want to pursue. I want to more. I want to more. If you have
Mm-hmm.
the hunger, you basically go a step further. So after 6 months, I start taking over my own projects. So I was given in
Good.
projects to design electronic hardware. For example, I think my first product that I designed was a signal distributor for in-home in-home communication
Okay.
for TV and internet. So it was a 3 month project. So the project starts. I usually start with a little bit of research.
Yes.
So at the company, we had our research database. So during my 6 months, I actually managed to to get through all the products that the company was doing. So
Okay.
it make it easier because
Yes.
you don't start from scratch.
Mhm.
There is no such a
You
thing.
normally
You don't
say,
start from
yeah,
scratch.
you
No,
don't
no, 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 no,
reinvent
no.
the wheel.
No, 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 no.
Yes.
You don't start from scratch. So the company has already the database because they've
Mhm.
been doing this for years, for
Yes,
years.
yeah.
So
Mhm.
what they actually want is just if you can actually come with a new idea,
Yes.
they will be able to, okay, yeah, you can actually apply, but it will go to a scrutiny. They hire the most senior engineers, will sit down, will look into ideas if it's
Mhm.
doable or if it's actually feasible. It can be doable, but if it's
Mhm.
not feasible,
Yes.
like no way. So I picked on my first project, 3 months. I think I spent 3 months doing that project, and the delivery was after 3 months. We start doing research. Basically, my day-to-day was like coming to the office,
Mhm.
and I would research on a database of the company, but also I would look into what the academics are doing to improve some aspect of my design
Yes.
because this is what I actually know. So I'll basically combine with my creativity. I'll look, okay, yeah, this is doable. So let's try
Mhm.
and apply that. And then as soon as you finish your research, you start designing your module. So by simulating using computer tools, softwares,
Mhm.
tools, and then after you're simulating, if your simulation goes according to what you expect from
Yeah.
your research, from your calculations, then you start prototyping. So the
Mhm.
prototype is like the process of you basically taking your idea from your computer, from the paper, and bring it to the real life.
Mhm.
But you don't need to actually forget about. You need to basically remember all the aspects that
Mhm.
are actually very important for your for the product, which
Yes.
is for whom you are designing and the safety standards. So you need to follow standards
Yes.
because the product will go, someone will use the product. So if that product is in someone's house and sometime at some point in time it doesn't work as it's supposed to, and then it caught fire, someone's house is gonna burn.
Yeah,
So
of course.
you want to avoid that.
Yes, yes,
So
yes. Good.
so you need to look into that as well. And also you need to look into how much money basically you are using it to build your project. So you need
Yes.
to look at that. So that thing will go into the components that you are using. If the components is expensive, but yeah, component is expensive. So you don't want to use expensive components. But sometimes expensive components they bring you
Yeah, the
the best
quality.
performance.
Yeah,
But
performance.
yeah, so is that trade-off that you need.
Yes.
You need to basically think a little bit more
Yes.
how you can solve that problem.
Mhm.
And so after that, I think I missed one point. The first point in this whole thing was you receive a specification from the customer,
Oh,
from Virgin
yes.
Media,
That's the key.
from Virgin. Yes, that's the key. So
Mhm.
otherwise you basically design something out of the blue.
Out of the blue
But
end,
yeah,
you won't
so
go
before you
anywhere.
start design, yeah, before I
Mhm.
start designing, I receive the specification. So it's customer specification.
Yes.
So where you have basically all the let's say voltage level, um, I would say power level,
Yes.
um, yeah, all of these parameters that you need to look at
Mhm.
as on the electronic side.
Yes.
And there are some mechanical sides that I was not concerned about it
Yes.
because basically I was working a group of engineers and
Mhm.
my input was on the electronic side.
Yes.
But the electronic specification, so you just need to follow the electronic specification. So is the customer always wants the best of
Of
everything.
course.
Always they
Yeah.
want the best of everything. But it's down to the engineers to
Yes.
convince them or to make to present the best solution
Yes.
for the means that is available at the
Yes.
moment, is down. So
Mhm.
after getting the specification, I'll do my research, and then after the research, I'll basically have my simulation ready, and then after my simulation is ready, I will basically move to my prototype. And then as soon as I built my prototype, I would go by basically testing my prototype, doing all the various testing, and then checking if my testing actually goes according to what the customer is specifying. If it goes as how the customer specifies, I'll basically say, okay, I'll give my test to another group, which is quality check.
Yes.
So they'll check the product if goes according to the specification, and then it goes, we have another review. So it's a peer review inside of the company where the most senior engineers will come sit down with you and check why you take all of those decisions.
Yes.
And then you need to basically justify, look, I did this because it will help with this performance or with that performance. So that was my experience at the company. So that basically that was the day-to-day. So I would say the sales engineer will basically contact Virgin Media and ask if they have any problem or if they are missing something, or if he find a project, he'll bring the project to the company and say, look, the Virgin Media has this project.
Yes.
They want to build this type of product. And I think I told them it can be done. It's always sales engineers are like that.
Yes.
So, and then we have a meeting, and then this meeting is where an engineer is there. Most of the engineers are there, and then they actually start basically assign who's gonna do what on the project. And then after it's decided if the project is feasible and can be done, we have like timetables when you need to achieve what is on the list. So when you need to provide the prototype, when you need to provide the designs for massive production, and when mass production is gonna start. So it's in that meeting. So that was my day-to-day. So they give me a project. They say you have 3 months. In this 3 months, I'll create my own timetable, and then on my own timetable, I always allow time for anything that can happen, because you never know, the project might go sideways, and you need to know how to bring it on track. So that was my I think that was my my process after my 6-month training. So I spent 2 years in that company from 2018 to 2020. But I think April 2020, we had the pandemic, and the pandemic hit, and the company was not doing that well because we were mostly relying on China to mass product our products. So we had so many products in the production line in China, but we couldn't sell them.
Wow.
Because there was lockdown here, there was lockdown in China, factories stopped in China, and they start cutting jobs. So as a junior engineers, you're always on the line of you're always on the line.
To save the senior first.
Yes, they want the seniors first and the junior.
Trying to push you away.
But the good thing was during the pandemic, when they were cutting jobs, I was made redundant. So it was a very tough time, and I was like trying to manage, and also as a immigrant worker, as an engineer, immigrant worker, you basically you have like you are working on a visa.
Yes.
So and the visa is given to basically the visa process is kind of tricky, but it's given to you are only entitled to work for the organization that provide you the visa, the sponsorship.
Yes.
So even if your visa runs in 2 years, but if your job is cut short, you cannot work for anyone else during the rest of the period. So you need to reapply. So in order to reapply, you need to find a company who is actually eligible to provide this type of job.
So when you
Like,
say when you say you had a bit of experience in programming, maybe that is probably going to help people to also understand that when you
yeah,
talk about electric engineer, you also deal with programming. So is it
yeah.
that the programming that you cover at university, or was that you learn one programming language in university and then after that you try to pick up another
Um,
language?
yeah, I think at university, when I was at university, I learned the most. I think I think the most important programming language for electronic engineers, which is VHDL,
Okay.
C programming,
Yes.
and you learn a little bit of assembly, but assembly is basically is the root.
Yeah, it's
Is
the root.
like is machine language.
It's
Is
machine
a
language.
very 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 ancient language,
Yeah.
but you only learn that to give a little bit of perception what is actually happening inside of the chip,
Some
how the
kind of say
communication
that
is done.
it's a
Yeah,
scary language, you know, because
yeah. So that
so
was actually that was the first that was the first programming language I learned.
okay.
But then, I mean, I'm wrong. That is not actually true. The first programming language I learned was Java.
Oh,
Was
Java.
Java when I was back home,
Okay.
because back home I was already on my first year at university, so
Okay.
in Angola.
Hmm.
Probably most of the people who will be watching this, they don't know. So I'm from Angola, and I came in the UK as a student. But before I came in the UK as a student, I was already a student in Angola. So I was doing my first year in oil engineering. So in my first year, I learned Java, but then I have to drop out in order to come to the UK
Come to the UK
and
to continue.
basically, yeah, continue with my
Mhm.
studies. So when I came to the UK, I on my first year at university, my first year and second year at university, I learned assembly language was the first language I learned, and
Mhm.
then I was introduced into C, and then VHDL. So assembly language is a type of language that is more primitive language. So
Yeah,
it's a like
machine.
machine level
Yes.
machine level language. And
Mhm.
then and if you basically understand how is assembly, you
Mhm.
basically understand how the communication side of any chip works. And then I learned C. By learning C, actually, it was quite. I think it was quite intuitive. And then I learned VHDL, which was a program language for FPGAs.
Okay.
Is a different type of I would say it's not microcontroller. It's a different type of microcontroller,
Yes.
but it's a high speed microcontroller,
Mhm.
and then it's very flexible. You can do so many things with the FPGA. So, and you can actually we use VHDL to program FPGA chips. So to
Okay.
design logic gates. It's more into digital electronics.
Mhm.
So VHDL is more for digital electronics. So those were the three main language that I learned during
That's
my
good.
time at
That's
university.
that's quite good.
So at industry, if you work as an electronic engineer, you
Yes.
are very likely to use, I mean, you are less likely to use assembly language, but
Okay.
you are very likely to use C programming,
Oh, that's
because
good. Mhm.
C programming is a very, I think is the base of most of these high level languages like
Okay.
Python
Mhm.
or probably C sharp or something like that.
Mhm.
So, but it's in engineering, in the engineering, electronic engineering, C programming is the core.
Oh, it's the
So
core language of the program.
most of these
Mhm.
microcontrollers, most of these chips, they can
Mhm.
be easily programming into C programming. And then most of these environments that you can actually use to program, they have C and C++ as well. So in the UK, most of the companies, I think 2 years ago or a
Mhm.
year ago when I was applying, that was one of the requirements. You need to know C. and I think during my time at university here in the UK, I basically managed to learn quite a lot how to program with C. So during my first 2 years at industry, I work as a hardware engineer mainly, just designing hardware.
Okay.
I didn't actually work at, I think was once or twice that there were projects that they require a little bit of programming, but it was very rare. So when I went to London, work in London in a company that designs electronic device um, for safety measurements,
Yes.
um, like alarm sounders, beacons for big sites like oil fields, like factories. So you have all of these fire alarms, like CO2 alarms, uh, warning lights to basically direct you when there is a fire or something like that. And so I was brought in to basically feel the, so I was brought in to work as a software engineer, but they want me to have a little bit of hardware experience. So I had already hardware experience. So I took the opportunity to basically to learn a little bit more and to implement all the skills that I learned at university with programming.
I really want to highlight that, especially for young graduates who are finishing university. That thing that you say, it's very important. Sometimes when you finish university, it's important to take any type of job in your field just for you to get that experience, just to get that exposure.
That's right, yeah.
And then after that, you will have the flexibility. Around, because the experience is very important, you know. So
that is true. That is true actually, because I think when I went to that company, I felt more confident, and my confidence was so high, and I knew already what I was supposed to do and how to do it, how to deliver, how the process, how the protocols is working, how to get stuff done, how to order components or whatever for your own projects.
So all of those, did you cover it at university?
Actually, I didn't cover most of this thing at university. I covered most of this thing on my first junior level.
Okay, on your
job.
first junior level.
Yeah.
When you start up, yes.
Yeah.
Okay.
So it's where I cover most of my stuff. I think I learned quite a lot during my time at the company.
Okay.
And because I was being mentored by people who already been, like, they've been passing through what I've been through. So they've been trained as well. And then they knew the struggle, and then they came back to me and told me, "Look,
kind of relate to you."
Yes,
I was.
So
I was in your shoes. I can understand.
I was in your shoes.
Don't worry, you get it.
Yeah.
Take time.
Don't
be hard on yourself.
That I think there was this senior engineer. He was very helpful to me. And I really appreciate his help, and actually learned quite a lot with him. So I basically, the type of job I was doing 2 years ago was more hardware design, but is in an area that probably in the next 20 years that kind of technology won't be used anymore.
Okay.
It will be, because as a radio frequency engineer, I don't know if you've been following with how 5G is working and all of these things.
Yeah, there's a lot of talking about 5G.
There's a lot of talking. So basically, my job was designing broadband equipment and broadband TV mainly, and TV mainly.
Okay.
They work in a band that is around, let's say, I would say 1 megahertz to 1.2 gigahertz.
Okay.
Right? But now is the demand of information. the band is not the band to basically transmit all of this information that we need, because there are more people streaming videos, video game, internet, music, all of these things.
Yes,
It require a much wider band.
yes.
So in order to do that, you need to extend your frequency spectrum. So you need to go probably, if you are 1.2 gigahertz, you need to go probably to 1.8 or 2 gigahertz. But the problem with that is the components that you use to make these equipments to transmit your information, they won't behave the same way as you increase your frequency. So like the type of technology that you actually use there, it changed. So yeah, the company was more into passive components, which are resistors, inductors, and capacitors. So we were making most of these transmission telecommunication devices with this type of components. But the problem is this type of technology at some point, because of the variation, they are frequency dependent components.
Yes.
At some point, if you increase the spectrum, these components will start being unreliable, because the behavior will change. So you need another type of technology. So with this in mind, I like to learn. I like to keep updating myself,
which is really good.
So I was reading this book called Microcontrollers with microcontrollers, and the engineers that was basically my mentor there, he saw the book on my desk, and then the guy came to me and said, "Oh, this is a very nice book, Denilson. You know, I advise you. You are very young. I advise you to keep learning what is in this book, because in the next 20 years, this company probably, or this business probably won't exist. So don't get too tight into it, and then try to basically learn what you have in here, because the world is basically progressing to automation. The world is there is so much things in our houses that are being controlled by a software, but those softwares, they already installed into the machines that you use. But most of people, they don't know that. When I was made redundant, I went to London, and then I took this opportunity to apply what he said to me, and then I said, okay, I will try that. So I was hired in a 6-month contract to work as a software engineer. So during my time, my day-to-day was mainly, so the products that we install, like fire alarm that you have in your house, or probably let's say light detectors or whatever that you put it to alert someone that there is danger. The customer can customize the way they want. They come to us and say, look, I want this product, but I want this product to behave this way. I don't want the product to do this sound. I don't want the product to basically to flash in this pattern. So because the hardware is already done, what you need to do now is basically to redesign the software to accommodate the changes that he wants. So for example, if you have a sounding alarm, if there is a fire, he wants, let's say the customer might come and say, I want to have a siren, but the siren need to be 5 minutes on, 5 minutes off, 5 minutes on, 5 minutes off. So the hardware is already done. You just need to change the software. So I would come. I have this. My manager would say, Denilson, look, we have this software. This customer wants this software. Can you do it? How long can you do in 2 days? I said, yes, I can do that. So I would sit down and then grab the software, because the software is already there. So I'll grab the software and I'll make the changes. And as soon as I make the changes, I'll test on the hardware if actually does the siren for 5 minutes on, 5 minutes off.
Mhm.
And then if it does, I will basically test and see if there is any bug or any sort of problem in the software. And if you pass that, I would show to my manager and then say, look, this is what we got, and then this is what the software can do. And then I would like send him videos or audio, whatever, to send to the customer. And customer would say, yes, this is what I want, this is agreed. And then we go to production line. They will basically download the software into 1,000 products, and then they will
Wow.
ship to whatever
Quite impressive.
they want.
Yeah.
Yeah.
How do you become an electronical engineer? Do you need to have like a bachelor degree in electronical, or if somebody don't have a degree, can they also penetrate their industry and become electronic engineer?
I think, yeah. I think it would depend where you are. I would say I would give an example here in the UK, because at the
Okay.
moment I'm based in the UK.
Hmm.
So in the UK, everyone can be electronic engineer,
Okay.
but the professional recognition comes from, I think, a regulator entity.
Or
So
regulator.
for electronic engineer is the IT, which is the Institute of Electrical Technology.
Okay.
So you can apply to, at the moment, I'm a member of this institute,
Okay.
but you, to have professional recognition, to actually say, yes, you are professional, recognized as electronic engineer.
Mhm.
But rather than that, anyone can become an electronic engineer. So I'll give an example. At the company where I start,
Yes.
when I finished university,
Mhm.
there was a few guys that were called technician.
Mhm.
So they didn't go to university at all. What
Okay.
they did is they did a college degree, which is
Okay.
like, I would say,
Like a foundation
like
degree, sort of.
it's not a foundation degree. It's more like apprenticeship, like,
Okay, like a sort of like a diploma or
So
something.
yeah, it's like a diploma,
Yes.
where you learn a profession. Yeah.
Yes. Mm.
So it's not high education. It's more like more application of, okay, you want to become electronic engineer, so we're gonna teach you the basics. So
Yes.
they'll teach you how to basically solder, how to analyze circuit and whatever,
Mm-hmm.
and then they give you a diploma at the end of your course. It might take probably 1 or 2 years to get a diploma.
Mm-hmm.
So when you finish that, you can become apprenticeship. You become apprenticeship, and then after, I don't know how many years, after a few years, you become a technician.
Yes. Mm.
And then to become a junior engineer, it takes a lot of
Okay.
time.
Okay.
Yeah, it takes a lot of time, probably 3 or 4 years, and then you become a junior
3 or
engineer.
4 years. Okay.
And then to become an engineer, it
Yes.
might take another 2 or 3 years to become an
Wow.
engineer. And
Okay.
then to become a senior engineer, it will take a lot of time. So actually, you can go through the whole process of
Okay. Go through
become
the
to
whole
the
process.
seniority to whatever,
Mm-hmm.
but it's just a long process
Long process.
because
Okay.
it requires you to do more.
Okay.
Whereas when you're at university, they shorten this process. So when you come
Okay.
out of the university, you go straight as a junior.
Okay.
So when you come from a professional college, you go straight as apprenticeship, and
Okay.
then start technician,
Start
and then a
taking,
few years junior.
you're progressing.
So yeah, and you're progressing.
Mm-hmm.
So here in the UK, you can actually become an electronic engineer without going to university, as
Okay.
long as you are interested
Oh,
in
interested. Okay.
in in the field,
Okay.
and and
Okay. To
you
learn.
have and you have some kind of low level qualification. It could
Okay.
be a diploma. So you
Mm.
start with a diploma, and
Yes.
then you get some experience. As soon
Okay.
as you get the experience, let's say you are engineering level,
Mhm.
you're already there. Just try to be as much curious as you can,
Okay.
because if you are not curious,
Mhm.
you won't learn. I think was one of my thing. I
Mhm.
think one of my problem was at university. I was just into the academic world. I
Okay.
didn't I didn't actually look into like how the industry work.
Okay.
But if you're curious, you want to explore what is outside, and
Okay.
you see it by asking, because at the moment there is a lot of platforms that you can actually asking people
Okay.
how the industry is, if you have an idea how you want to go to the industry. And the
Because.
second one will be uh, just try to be as consistent as possible and disciplined, because
Mm.
right now the world is very competitive, right?
Okay.
Electronics is a very mathematical and physical based and
Yeah.
discipline. You just need to know how to basically manage your time. You need to have good time management, which is my third advice. You need to know how to take breaks, because sometimes you need to take breaks as well. You need to go enjoy yourself, because that thing will help
Mhm.
you restore your energy, your brain, your focus, and then you come back more refreshed.
At Yekola Academy, we also provide online courses. So, what you advise on, because you have to be open to, to learning,
I think I would say I would speak in a more broad way.
Yes, sir.
Um, um, Most of these online courses, they are very fundamental
Yes,
for
sir.
the completion of
Yes, sir.
many undergrad degrees,
Mhm.
because uh, because how these courses are designed, they basically give a shortcut how the lectures at university are.
Okay.
So they go to the point, you
Yeah, they
know,
go to the point. Yes,
they
sir.
go to the point, and
Mhm.
sometimes is what you need, because you need that flexibility of
Yes, sir.
like, I need to shorten the time because I need to look into this particular module, but I need to learn this bit and that bit.
Yes,
So
sir.
if you go into a very long theory that it will actually take lots of your time to basically read it through,
Mhm.
and which is are like most of the textbooks right now.
Yes, sir.
So the online courses and most of these online platforms, they actually come and shorten that time that you actually would spend
Yes,
reading
sir.
it. And these days, to acquire knowledge is even easier because of the spread of the internet,
The internet and
of
yes,
the
sir.
social medias.
Yes, sir.
Information is out there. You can do whatever. There
Mhm.
is so much information on the internet that
Yes, sir.
you can actually do things that are completely incredible.
Yes, sir. Yes,
So
sir.
I think at university, I would say I spend more time uh, with online courses and online platforms
Okay,
rather than
that's interesting. Yes,
reading
you
textbooks.
end up
But
performing
I'm
better as well.
yeah, yes, true. So it's a plus by basically using online platforms, and I'll definitely advise it.
In Africa, there's a say that when an elderly person die, a library is banned. You know,
That's right. Yeah.
because they will go with all of this information. But I want to challenge all of us to change that. I want when the elderly person die, we don't have to ban the library. He or she have to pass that information to the younger generation.
To the younger generation.
So
Yeah.
that's where the point that you were saying about sharing, because education, the knowledge, we need to share it. We need to pass our experience, to the younger generation so that they can learn and to do better things, especially
That's
in,
right. Yeah.
in the digital era that we are living right now. There's so many things on internet, you know. All you need somebody just to guide you, to give you a direction. You can actually sit at home and build one of the most sophisticated,
Sophisticated
you
things.
know,
Yeah,
gadget out there just by watching videos, learning from others and all that.
that's
So
it.
yeah,
Yeah,
it's a
that's
very
it.
exciting time, you know. So, and the key word that Denilson is keep on repeating is you have to be curious. You know, I will
Yes,
add,
yes.
you need to be open to learn, you
To
know,
learn. Yeah, that's it.
you
You need
know,
to.
IT
Yeah.
or electronic or engineering field, it's forever changing. So you have to be, uh, you know, like open to learning, you know. So which is, yeah, thank you very much. Thank you very much, Denisa, for your
Yeah.
time. And for those who don't know, yeah, he's also one of our instructors as well in yeah, C programming language. Yeah,
Yeah.
once again, thank you very much.
Thank you.
So,
Thank you. I really
and
appreciate
thank
that.
you to everyone who's going
Yeah.
to watch this video. Thank you.